So, anatomy of Bayes' theorem. This is going to cover the part of Bayes' theorem that basically provides the magic and the approach that we use in Bayesian statistical analysis. So let's talk a little bit more about what Bayes' theorem is. So here we have, Bayes' theorem. I put this in the context that we used in the earlier part of the course. Sometimes instead of an E, you'll see an A here. Instead of a T, you'll see a B here. But I want to keep this kind of focused on how we might use it in pharmacology or toxicology. So here again, this part right here, P, E given T, is what we actually really care about. This is what we want to calculate. This is the probability of the effect E given some treatment T. Like I said, we call this the posterior probability. And it's the posterior because the prior is over on the other side. And that is PE right here. This is the prior probability of effect. If we have historical information or we have information from other studies that we're using, it'll all be represented right here in PE. Now PT given E right here, this is what we call the likelihood. This is the data that we're getting from the study. If we want to think about a medical test as a different kind of example, this is where we would get our test results. So like if we were taking a cancer screening test, this is where we'd put our probability of our particular result. So that would be the sensitivity of the test would go there. And then PE in the medical diagnostic example, PE here is the prevalence of the disease. And then PT, this is a normalizing constant, which ensures that the posterior is going to be between 0 and 1. This is also, in our particular example here, the probability of the treatment being true. So before we can dive into Bayes' theorem in great gory detail, let's deconstruct what this whole T given E or E given T is. And these are what we call conditional probabilities. So it's the probability of the effect given some treatment, and that's a conditional probability. So if we deconstruct that part, the conditional probability, a little bit more, this P with the parentheses, of course, that represents probability of something within the parentheses. So A here is event A, B here is event B. So A bar B is said event A given event B. So if you put it all together, this would be the probability of event A given, that's what the bar means, event B. So here's some examples of conditional probabilities that you might find in real life. For instance, the probability that I eat sometimes food, sometimes we call those junk foods, given that I am hungry. We could make this even more complicated, given that I am hungry and that it's after midnight. There's the probability that I bring an umbrella because it is raining. And another one is the probability that I have a stubbed toe given that I am playing football or soccer, depending upon what part of the world you're in. So these are all examples of conditional probabilities. And what's important to know about conditional probabilities is that it really is focused on this first part given this second part. And let's be very clear. We know from Bayes' theorem that the probability of A given B is not the same as the probability of B given A. And again, we see that in Bayes' theorem. So to be clear, what this means that the probability that I eat sometimes food given that I'm hungry is not the same as the probability that I am hungry given the fact that I eat sometimes foods. The probability that I bring an umbrella given that it is raining is not the same as the probability that it is raining given that I'm carrying an umbrella, and so on. And so we need to make sure that we understand that the probability of E given T is not the same as the probability of T given E. And again, we know this because of Bayes' theorem. We can also figure this out through common sense as well. So now that we have all of this about Bayes' theorem, in our minds, and we know, okay, so, it's going to be the proportional to that numerator where we've got the prior probability and the likelihood. And, the thing that we're looking for is this posterior, and these are conditional probabilities. Now that we have this foundation, and really Bayes' theorem is that simple, now we're ready to start coding.